All right, for those of y'all who are watching the recording, I just started the recording after lecturing a little bit, but I think it's okay. You're just going to need to go to slide 29. What we're working on is searching an array. We're kind of modifying this code to our own example, which looks like that. So go ahead and, well, let me close Visual Studio. That's going to keep confusing me if I go there and there. So this is what it looks like. This is what we've got so far. Int main. We've defined the size of our array. We've declared an array of that size. And what we're going to do is we're going to search this for a specific letter. Let's say we want to find the position of the A. So I'm going to declare something called target. And that's what I'm looking for. That's my target character. If I find it, perfect. And now I just need an index variable. Whatever. So I can have a for loop or while loop, something like that. So for I is equal to 0, I is less than the maximum size of our array, I++. Now let's check the character at that position. If C array at index I, is equal to our target, then good news, we found it. I found equals I. And we may as well stop looking at that point, so we could just break out of the loop at that point. So once we get here, if I found is greater than or equal to 0, it means that we actually found it in the string, in the array. The fact that this is an array of characters means nothing. It could be an array of ints. It's just that our target would be an int. It could be an array of doubles, whatever. Okay, so if we find it, let's let them know. Printf, single quote, %C, single quote, was found at position or index, found at index, %D. \n, end quote, comma, target, that's our character that fills in the %C. There should have been a comma there. Can I close this? Good. All right. Comma, and then I found, the index where we found it, I capital F. But if we didn't find it, that's a bummer, so we're going to print an error message to that effect. Single quote, %C, end single quote, was not found in the string. Now maybe we should have displayed what the string was. All right, let's build it, see if it works. Then I'll bring the code back up. Sorry to cover the code up. Yep, so it found the lowercase a at position 3. And if I scroll back up to where that was defined, I'm going to remove some curly braces to make the code more compact. Then index position 3 is in fact 0, 1, 2, 3, a lowercase a. So it found it. But what if our target was X? Would it be able to find it? Nope. There's no X in Oklahoma, so it's not going to work. Wish I could get out of the habit. You have to close the window in Visual Studio, and if you close it, in Cygwin, it doesn't work. And so it didn't find it. Now, I'm not sure why I'm seeing an empty thing there. I think I goofed on my print statement. Oh, yeah, what did I do wrong with my print statement? When it didn't find it, it didn't print the target character. Yeah, it's just because I put the placeholder there, but I didn't actually fill it in. Okay. So that is how you search for an element in the array. If the array is sorted, then there's some things you could do to speed up searching. If we knew that the array was sorted, then once the value got too large, like if I lined up everybody in here and I was looking for somebody whose name started with an F, then whenever I got to Greg or somebody who was past an F, I could just stop searching there. Better yet, if it's sorted, you can do something known as a binary search. If it's 100 elements long, you check position 50. It's like that guessing game. I'm thinking of a number between 1 and 100, and so you guess 50. And they say, no, go lower. So you go 25. And they say, no, go higher. So you go somewhere halfway between 25 and 50, 37. And you can either zero in and find out that it's going to be there or that it's not going to be there. And if you have 100 elements to search, if you can do a binary search that way, by zeroing it in half every time, you'll always find it within 7 or 8 searches, or you'll rule out that it's there, which is a lot better than having to start at the beginning and run all the way to the end, which is how you would otherwise have to rule out its presence there. So sorted data is nice, but at this point we don't have any. I don't know if we have sort algorithms or not. We could write some. Could be that the C library has some sorts. I know that the code is out there. We could go and find it. So yet again, we see that we're using a loop to access the elements in the array. An alternate way of doing it. Using our counter as our iFound variable. And what do I mean by that? If I runs all the way through here and it doesn't find it, if we get to here without ever having found it, what is I going to equal? Well, we kept running as long as I was less than a size. So if we got here and I was equal to a size, what does that mean? Means we never found it. Does that make sense? If this is counting from 0 up to 1 less than a size, if it ever gets to a size, we didn't find it. So we could take advantage of that. I is equal to 0. Actually, we wouldn't even have to stick that. We can just make that as part of the for loop. For I is equal to 0. Keep running while I is less than a size. And our C array at subscript I is not equal to our target. Semicolon. I++. Now there's nothing even to do in here. This entire for loop does it all. We don't have to do anything in there. And so if we're going to check it, we're going to check. If I is less than a size, it means we found it. Printf, we found it. I'm going to take the braces out. Else, printf, we didn't find it. And let's go ahead and say what index we found it at. We found it at index %d, just like before, and we could put in I here. Now using a single letter variable name for this kind of purpose is kind of tacky, right? We should give I a better variable name here. It ought to be called found at or something like that. But the idea is the same. Start at the beginning, keep searching, and as long as I is less than the maximum size of the string and we haven't found it yet because that position in the index, that element is not equal to our target, keep going. I need to just make a makefile for this since I keep accidentally closing it. GCC July 11.c -ot.exe. Okay, so it was looking for X and it did not find it. That's to be expected. If we go back up here and change it so that it's actually looking for a valid character, how about capital O? Ought to find it. Please stop doing that. Okay. Okay, fine. Sorry, my... I'm not seeing why that didn't work. Cannot execute binary file, executable format error. GCC minus WALL July11.c. Well, that seemed to work. Minus O July11.exe dot backslash July11.exe. Alright, and it did fine. It found the capital O. And I will successfully remember not to close that window this time. So this is a more minimal syntax for finding it right, but it's the same thing. What I would really ultimately do is I would bundle this into a function. A search, array search, something like that. And so I think I'm going to go ahead and do that. We're going to write a function. We're going to come up above main, and it needs to return either the position where it was found or -1 if it doesn't find it. So int array search. And what are we going to take? We're going to take the array, char array, like that, and then we're going to take the target, and then we're going to take the length. And we could use either one. Which one y'all like better? Dap, you like that method, the short, concise method, or that method?
Short one.
Pardon me?
The short one.
Well, let's do that one. Yeah, all right. So we're going to need our counter variable. I'm going to call it I found. We're going to write our for loop. For I found equals 0. I found is less than length and ampersand array subscript I found not equal to target I found plus plus. That was all supposed to be part of the same string. I guess I'm going to break it up like this. Those are the three parts of my for statement. Put some dummy curly braces in there just to indicate that nothing is happening in here. And so if I found is greater than or equal to length, then we didn't find it, and we're going to return a -1. Else we're going to return I found. If I shortened I found to something a little bit easier, like IND for index or something, it might be a little bit nicer. All right. All right, so when we're going to test it out, I'm just going to test it out right here under where we declare the array. So I'm going to make a new variable called found_at. And I'm going to set it equal to array search. What's the array I'm searching? C array. And I'm searching for a k, lowercase k. And the length of my array is 10, or a size. And then let's just print out found_at, not add any complex if statements. So printf found_at equals %d \n, comma, or end quote, comma, found_at. Now there's some chance that I typed all that in without syntax errors. No. Expected a character, but argument is of type char star. Oh, do you see what I did wrong? The problem is here. It needs to be single quotes because a character is defined with single quotes. If I wanted to modify this code so that it could search for a string within another string, we could do that, but it'd be slightly more complicated than what we've done here. Okay, and when I ran it, it said that found_at was equal to 1, so it did search that string. It found the k, which is at position 1, so that is accurate. If I search for something that doesn't exist in it, like a z, and I run it, then found_at is equal to -1, meaning that it didn't find it. So the last thing I'm going to do is I'm going to come add some comments here, saying what this thing does. Searches the array for the target, returning its index or -1 if not found. So our code till now, if you're typing this in at home, you need to eyeball it. That's the function. Here's the first part of main. And here's the rest of main. So summing an array. To sum an array, you just rip through it like we were searching for it, except we're not using any ifs or anything. We just add values up. Now we don't happen to have an array of numbers to add, but we can do that. I guess down here right above my return 0, I'm going to make a new array. An array of ints, an array of doubles, it doesn't matter. Double scores is equal to 31, 32, 33, 34, and 35. So double total, or sum, is equal to 0, and then we're going to write a little for loop to run through it. For I is equal to 0, I is less than the length of that array. I don't have a variable for storing the length of that array. Since it's in the same context as we are in, we could use the size of trick. Size of scores divided by size of scores subscript 0. And then I++. Now is that a great way of doing it? Well, it works. It would have been better just to define the length of the array as a constant. But let's say we didn't know. And then total plus equal scores at position I. what would be kinder is if we at least did this calculation before the for loop, because otherwise it's being reevaluated every single time. And what if the array was, 1,000 elements long? Would we want this calculation, this 2 calls to the size of function and a call to the division operation? So why don't we go ahead and int score size is equal to, and then let's put that size of business right there. So I'm going to take all of that, put it there instead, and make this just say I is equal to 0, I is less than score size, semicolon I++. Now let's print out our array. Same tactic, just a for loop. For I is equal to 0, I is less than score underscore size, I++. Why don't we print the word scores in front of it? So printf scores colon space, but no \n because we want all these scores to be on the same line. Then inside the loop, just printf. Now these are floating point numbers, so I'm going to use %f rather than %d like I kept doing on Monday. And I'm putting a space there so that they'll all be separated by spaces. Followed by score subscript I, the particular element we want to print. Now let's print out a carriage return, so it'll go to the beginning of the next line, and we can print out the total that we actually calculated above that. So printf quote \n total equals %f \n total. All right, I've got a boo-boo. What did I do wrong?
You're missing an S on your array right there. Score is not.
Oh, score rather than scores. Okay. So, anywhere I have the singular word score, I need to fix that. It looks like maybe that's the only place. Yep. All right, so there's my scores. The total, I trust that that's correct. Now there's the concept of a partially filled array. A partially filled array is when you're starting to add data to it, but the whole array doesn't have good data yet. See, this is great. We filled it full of 5 values, but how did we know there were going to only be 5 test scores? What if there were going to be 500 or 5,000? We might have to allocate the array larger than the amount of data that we currently have in it. Why? Because you can't add elements past the end of the array. If we allocated scores to be 5, but then we needed to add elements 6, 7, and 8, it's a real problem. So quite often you wind up allocating the array larger than what you need, and you only fill in certain pieces of data. So if I did this, I'm going to revise this code. I'm going to call this tests rather than scores. And why don't we just use ints because they're easy. Int tests. We're going to support up to 10 tests. Let's initialize them all equal to 0, just for simplicity's sake. Let's print them all out. We should make a print array function so that we don't have to keep doing this. You see that 10? I think I'm going to define it as a constant. Townsend define num tests 10. So that here I can do num tests, and I can keep doing that over and over. I is equal to 0, I is less than num tests. July plus plus. Print F. Percent %D, because we're curious about which index we're at, equals percent %D backslash n. Or maybe just a couple of spaces. I don't know. And then end quote, comma, I, comma, tests subscript I. And let's print out a backslash n just to end things up. Right now it's going to be all zeros. But what if we started adding data to it? What if we let the user enter 3 scores to it? Well, if we were going to try to calculate the average and we added those 3 scores together, but then divided by 10, it's a real problem. And I launched the wrong thing. Lost Sigma. By the way, if you don't want to put that .exe there, you can leave that off, and then you can run it as just doing .July 11 without typing in .exe. Okay. So when it ran, it printed out all of our scores. What if we started adding some scores to it? What if we wanted to fill in 3 test scores? Now, we should ask the user for these scores, but I'm just going to assign some. Test subscript 0 is equal to 31. Test subscript 1 is equal to 90. Test subscript 2 is equal to 40. Test subscript 3 is equal to 0. Test subscript 4, they made up for that 0 by making a 100. So when I run it, when I build it and run it, GCC July 11 dot C minus O July 11 dot slash July 11. Our scores are there, right? 31, 90, 40, 0, and 100. But if we sum them all up and then divide by the number of scores, well, the number of scores, all we know right now is the size of the array. Let's get our total. Total is equal to 0. Tell you what, just steal this code, copy it, paste it, and replace that printf statement with total plus equals tests subscript I. And let's calculate the average. Double average is equal to total divided by what? Num tests? That's not really a very good answer because there aren't 10 pieces of data in there. It's only partially filled. It's only half filled. It's only got 5 values. So when we print out the average, it's not going to look too great. Printf total equals percent %f, comma, average equals percent %f, backslash n, end quote, comma, total, comma, average. And I think didn't I already define the word average up here, or did I not? Is that going to be a syntax error? No, I never did. Okay. Okay, so there's all of our scores. The total is 261 and the average is a 26. Now just eyeballing our data, does it look like the average really ought to be 26? No, the total is 261. The average should be what? 261 divided by what? 5, right. We have 5 pieces of data. But we don't have any counter that indicates that. What we need is some way of tracking how many tests we have filled in. Maybe a variable called test count. Int test count is equal to 0. And each time we add a test to it, let's increment test count. I put it on the same line. That's kind of poor, but you get what's going on there. Every time we add a new piece of data to it, we're going to increment our test count. And then down there, when we calculate the average, we're just going to divide by test count rather than divide by the total number of tests. So down here where it says average is equal to total divided by num tests, I'm going to replace that with test count. I'm going to take out some braces so that the code can be held comfortably on the screen. It's unlikely that we would be doing it like that. It's more likely we would be in a loop, right? Asking the user to enter a number. And each time they entered a number, we would increment test count by 1. And the average is 52. Much better average. There is still one bug left in this code, which is that what if, let's comment all but one test score out. So now when we get here, what's test count going to equal? It's going to equal 1. We ought to see that there's an average of 31. And I'm going to put a /n in here because I'm tired of seeing all the data concatenated. All right, so we got an average of 31, which is to be expected. What if we didn't even have that? What is our test count going to be then?
0.
It's going to be 0, and what's going to happen when this happens? It's not going to be good. Average is equal to not a number. Okay. We could shorten this stuff up a little bit because you see where it says go to the number of num tests? We could do test count there instead. So it would only print the number of tests that we really had. Test count. Test count. That's not going to change the way this total is added as long as it was all zeroed out. If it wasn't zeroed out, that'd be very beneficial. We wouldn't be adding any elements that hadn't been already assigned a value. I'm going to uncomment a few of these, that 31 and that 90 and that 40, just to kind of make sure that it looks nice. All right, and so it printed out 3 test scores. 0 is 31, 1 is 90, and 2 is 40. So just remember that that is a concept, the partially filled array. Sometimes you need to allocate your array larger than the amount of data you're storing in it. Quite often you need to. One case is when you're using a string, right? Because your string, you're letting a user type in something. You don't know how much they're going to type in. You need to give them a comfortable amount of space in which to type it in. You're asking for somebody's first name, you better not just make it 10 characters long. Their first name may be longer than 10 characters. And so if you're using scanf and they type in more than 10 characters, but your array was only 10, your string was only 10 characters long, then it's going to have memory overwrite past the end of the string. So That's a partially filled array. A string is often a partially filled array, but instead of keeping track of a test count, you just use string length, strlen, which searches a string for the null character at the end, and it gives you the same idea. Are we all good, or should I slow down? Do we need typo fixes? We're good? Okay. So to sum a partially filled array, we have to keep track of the current number of items. This is a little bit overkill. But assuming that we know the length of the array, we would keep going while x is less than a length and x is less than current number of items. This is just a little bit of paranoia here. What if the current number of items was set to a value larger than a length? Well, that would stop you from going past the end of the array. Our code as written did not need such a thing, so I left that out. We could have put that in there. We could go here, and where it said for every one of our for loops, we could have done I is less than, I've already forgotten what that variable was, num tests, and I is less than test count. That works, but it's a kind of a superfluous check as long as test count is accurately set. If you're worried about it, you could go ahead and leave something like that in. So a two-dimensional array. You allocate a two-dimensional array by putting on a second size declarator. A 3 by 3 array. This is item number 0, 0. This is item 0, 1. That's item 0, 2. This is item 1, 0, 1, 1, and 1, 2. This is item 2, 0, 2, 1, and 2, 2. Let's play with that concept a little. Let's declare a two-dimensional array of characters. Char A2D, an array of 2D, a two-dimensional array. And let's make it 4 by 4. Nah, 3 by 3. Now we could initialize it like this. The syntax looks silly, but it works. What are we going to fill it all with? Spaces, with periods, with A's? Let's do A's. We need 2 opening braces. And then inside the second opening brace, these are characters now, so I'm using single quotes around them. Why not A, B, and C? And then close that curly brace, and then a comma, and then open the next one. D, E, F, G, H, I. Now I've closed that curly brace, but I need to close my overall one, and there I'm good to go. Do you have to pad it out like that? No. Could you have done this all in one line? You sure could. But you see, it's effectively an array of arrays. This is an array. This is an array, and this is an array. So this row is its own array, this row is its own array, and this row is its own array. Let's print out something from that array. We ought to make a loop that would print out the whole thing. But just for now, printf element 1, 2 is %c \n. End quote. And let's specify that array. A2D subscript 1 in subscript 2 in subscript end parentheses semicolon. And so what is row 1 column 2? Well, this is row 0. This is row 1 and this is row 2. So this is row 1, we want column 2, that's element 0, that's column 1, that's column 2, so it should print out an F. I may put some comments out here. This is row 0. That's row 1 and row 2. All right, and the element at 1, 2 is in fact F. So write some code that'll change this G to an X. You go ahead and do that. Then I'll do it too, but I want you to go ahead and do it. What's that going to look like? You're going to do A2D, and then you're going to have a pair of braces. And you're going to set it equal to NX, like that. You just have to pick what 2 numbers go there in order to change that G to an X. So to process a 2-dimensional array, you use a nested loop. You use a loop inside of a loop. For me to properly process it, I'm going to need to know how many rows there are and how many columns there are. So I'm going to define those. Since Visual Studio was giving me grief about using constants, I'm going to continue to just use pound defines, even though it's tackier. Pound define rows 3. Pound define calls 3. And then here where I allocate my array, it's going to be rows and calls. Honestly, I don't know what the compiler would do if I didn't give it enough rows, or if I gave it too many rows. I'm more curious about what it would do if I didn't give it enough. They would probably the rest of them would be set to 0. But having that, I can write a nested loop. I'm going to need 2 counters. A row counter and a column counter. I'm just going to call them R and C. Int R, comma C. Those are my rows and my columns. For R is equal to 0, R is less than all caps rows, R++, open brace, for C is equal to 0, C is less than calls, C-O-L-S, C++, and let's just print out that character. Printf %C end quote, comma, A2D, because that's the name of our array. Guess we could have given it a better name than that. Grid, matrix, something. Subscript R in subscript, subscript C in subscript. End parentheses, semicolon. Now this is printing out a single row here. This is printing all the columns in one row. Once we get to the end of the column, we probably want to go to the next line. So I'm going to printf a \n there. Oh, I never filled in these numbers. What were they? 2 and 0? All right. That didn't work. All right. GCC 11 times C minus OK. And there's our array printed out as a grid. A, B, C, D, E, F, X, H, I. Any 2-dimensional array you would process in that fashion. If you wanted to sum up all the values, then you would declare your total here, and you would put your increment here. If you were searching the array for a specific value, then you would have your if statement here. And if you ever found it, then you would put, let's do that as well. Let's look for a character. Let's look for that X. We made an X, we may as well be looking for it. Target is equal to X. Fortunately, I think we already have that variable named from up above. And we need two indicators to show whether we found it or not. A found at row and found column. So int found row equals -1, comma, found column equals -1. Because we just have to have some way of knowing whether we found it or not. Okay, so we're going to repeat this code right here. You could just copy it and paste it. Just grab all that and then paste it underneath that. But instead of a print, we're going to have an if there. So I deleted that print, and if array 2D subscript R in subscript, subscript C in subscript is equal target. That's great news. We found it. So underneath that, I'm going to set found row equal to R, semicolon, and found col equal to C. And so down here, I just need to check. Did we find it? Did we not? If found row not equal to -1. We should check them both, but why? Well, we're only setting, yeah. If found row has been set, so is found col. If found row hasn't been set, neither is found col. Okay, so if found row is equal to -1, we didn't find it. Let's print a message to that effect. Printf %C not found in 2D array. \n, end quote, comma, target. Else, we did find it. Printf %C found at %D, comma, %D, \n, end quote, comma, found row, comma, found col, like that. And we did have an X in there, so I'm expecting it to indicate that it works. And something went weird. Found at 0, -2 million. Not what I was expecting. Not what I was expecting at all. Oh, what did I do wrong? Anybody see the error? The error's in this print statement.
You didn't put the target.
Exactly. I have 3 placeholders and only 2 values. So it should be target, comma, found row, comma, found col. And so X was found at 2, 0. Where'd all these /n's go? We sure do have a lot of blank lines popping up. Oh, when we're searching the array, we don't need to be printing out blank lines. So that print statement should go away. All right, so that's our code for searching that array. And that is really just about enough. There's more in the chapter, and there's also more in the PowerPoints.
Mine says X not found. Oh, that's just my typo. Sorry, it's fine.
Were you looking for a lowercase x?
No, I put in X. I typed not found. Wait,
Oh, yeah.
to print found.
Got it. Got it.
I thought it was a logic error, but it's a typo.
Right. Okay, so if we look at the rest of this, that's how you declare a two-dimensional array, except it's all being done in one place, right? And I don't think that that's accurate. I think that this should be a 1. No, that's a 2 by 4. Yeah. You can initialize it with a loop, a nested loop, just like that. You have to use a nested loop, see the code, or see what we just did. Any processing of a two-dimensional array is going to be done with nested loops. Displaying a two-dimensional array. We could display it, this would pad it out with a certain number of spaces per element. So if we were displaying numbers rather than characters, we would probably want to specify how wide we wanted it to be. I could do that. I could come up here and where we printed it out, I think I could do something like %4C, and then it would print it out nice, where the things were nice and wide. Like that. Okay. We are going to have to talk a little bit more about this stuff. Right, so I thought we were done with it. This is kind of a different topic, though. String cat and string copy and the other string functions. We'll talk about those on Monday. And then we're at the summary, and then I tacked on some extra goodies at the end. Iterating with subscripts versus pointers. We kind of talked about that, how arrays and pointers are the same thing. But here's one thing that I wanted us to hit, which is what if you need to allocate your own memory rather than declare it in advance? What if you don't know how long it's going to be and you find out that we're going to be reading a file that's 7,000 characters in? You don't want to just declare char CZ 7000. But if we can calculate how much data we need, we would wind up using malloc. Here's the syntax for malloc. You have to give it the number of bytes. So all this messy stuff is just calculating the number of bytes. And this returns a pointer to the amount of memory that has been allocated. After you're done using it, you need to free the memory. And so you call free and you pass in the pointer to the array. Remember, an array is a pointer and a pointer is an array, so we can use them indistinguishably. But we need to talk more about that. Why don't we take a peek at the homework? First we'll make a Dropbox, JK. All right, there's a Dropbox K. You can put your C file in there if you would. So I dropped another homework assignment on y'all after you left. Sneaky me. And here's where it works. This one, what I want us to do is to declare an array of 20 ints and fill it with random values. Just a single dimensional array. And then display the array, calculate the sum of the array, calculate the average, and then extra credit, calculate and display the standard deviation. You can Google how to do that if you want.
Yeah, I have a question.
Uh-huh.
I can't go there. I actually did it and I submitted it,
Oh, cool.
but I just did one C file.
Yeah.
And I wanted to do the header file and the functions, and because I
Yeah.
have functions.
I'm going to be right back. I'm so sorry.
Okay. Maybe, but it's not gonna see.
let me show the other homework and then I'll answer your question, okay?
Okay.
And then today's homework, grades array. Now this is actually just adapted from the book. So grades array. Create a student GPA average calculator. It should prompt the user to enter up to 6 GPAs, which are stored in a single dimensional array. Every time he or she enters a GPA, they should have the option to calculate the current GPA or to enter another GPA. Hint, be careful how you calculate the average. Don't include the unentered data. If we're going to calculate an average, you're going to need to know how many data items there are, right? So you're going to just treat it as a partially filled array, and as the user keeps going and adding more pieces of data, you would keep a counter. So here was my sample of the program. Welcome to the grading program. You can keep track of up to 6 grades. Grades. So far we have 0 of 6, and we printed them out. Do you wish to 1, add a grade, 2, calculate GPA, or 3, quit? So they type in 1, GPA of 3, that grade was added. So next it comes along, 1 of 6 grades added, and it shows that the first one is now a 3. Do you wish to add, calculate, or quit? We want to add another one, so we tacked on a 4. We came down here, 2 of 6 grades added. Do you wish to add a grade, calculate, or quit? So they chose 2. Well, the average of 3 and 4 is 3.5. Not 7 divided by 6, but 7 divided by 2. And it would be neat if it wasn't displaying these pieces of data, right? If it wasn't displaying all those extra zeros. If it showed that, But get the program working before you start worrying about things like that. And then they chose to add one more to it. We wound up with 3 grade elements. They calculated the GPA, it was 3.5, and then they finally quit. So things to consider: what happens when every element in the array is filled? Do you just quit at that point? Do you refuse to let them enter any more? You'll figure that out. Can you make the code so it's easily modified to support, say, 30 grades? If you do make the program show entered grades, because that's not a must, that's not what this asks for. This is the program specification, and it doesn't tell you to display the grades. I just thought that was nice to do. But if you do that, it'd be neat if it didn't display zeros for the data that hasn't already been entered. One idea that I came up with is you could just show like 6 underscores. Or show 6 nothing, right? You know, they don't, whatever. So if you do make the program show entered grades, it'd be better to not display zeros for the empty grade slots, but my example does. Okay, so you can probably think to yourself, I'm going to have a loop, because I need a loop to keep track, you know, so that it can keep looping, asking this question: do you wish to add a grade, calculate a GPA, or quit? And then in each time that they choose add a grade, you will write to the array at that specific position, and then you'll increment your partial array counter, your num items, your num grades, whatever. Does that make sense, y'all? Mm-hmm. Okay.